Okay, so in this exercise, we want to find the sum of products expansions of these Boolean functions. So the first function, f of x, y, z, is equal to x bar plus y. So we have two terms, and each term is missing a couple of variables. The x bar term is missing y and z. The y term is missing x and z. So we'll just introduce these terms. So first I'm going to say that x bar is equal to x bar times 1, and then I have plus. Y is also, I'm going to write it as 1 times y. Then I'll replace 1 by y plus y bar. So first introducing the y into the x bar term, and replace 1 by x plus x bar times y. Then I'll distribute. So this becomes x bar y plus x bar y bar plus x y plus x bar y. And I check to see if I have any terms that I can combine, any terms in common, and I see that I have x bar y twice. So I'll use the idempotent property that x bar y plus x bar y should just be x bar y once. So this is x bar y plus x bar y bar plus xy. Now I need to introduce the variable z to each of them. So I'll write x bar y times 1 plus x bar y bar times 1 plus xy times 1, and replace that 1 by z plus z bar. So this becomes x bar y times z plus z bar plus x bar y bar times z plus z bar plus xy times z plus z bar. So when I distribute, I have x bar yz plus x bar yz bar plus x bar y bar z plus x bar y bar z bar plus x y z plus x y z bar. And the last thing I'm going to do is check to see if I have any terms alike and attempt to combine them. So first I'll see that I have only one x, y, z, and then I'll look for terms where I have one complement. So I have plus x bar yz, I only see that once, and plus x y z bar just appears once. Then terms that have two complements are going to be plus x bar y z bar plus x bar y bar z. Each of those terms I just have once. And finally, I have plus x bar y bar z bar. So that will be the sum of products expansion for the function x bar plus y. Next, I have f of x, y, and z equal to x, y bar. So this one should be a little bit simpler because it looks like I'm only missing the variable z. So first I'm going to say x, y bar is equal to x, y bar times 1. And that's equal to x, y bar times z plus z bar. Then if I distribute, I have x, y bar z plus x, y bar z bar. So x, y bar z plus x, y bar z bar is the sum of products expansion of the function x, y bar. The third example, f of x, y, and z is x plus y plus z. So this will also be a little bit of a long problem because to the term x, I need to introduce y and z. To the term y, I need to introduce x and z. And to the term z, I need to introduce x and y. So my first step will be to write this as x times 1 plus 1 times y plus 1 times z. Then this will be x times y plus y bar plus x plus x bar times y plus x plus x bar times z. So when I distribute, I'll have xy plus xy bar plus xy plus x bar y plus xz plus x bar z. And then I want to look to see if I have any terms in common. And it looks like I have xy twice, but I know that I have the idempotent property, so I'm just going to write this as xy. xy plus xy is xy. And then I have xy bar, I have x bar y. So the others, I just have one of each, so I'm going to write plus xy bar plus x bar y plus xz plus xz bar, or x bar z. And again, I still need to introduce one variable to each. For the first three terms, I need to introduce z, and then I need to introduce y to these last ones. So I'm going to write this as xy times 1 plus xy bar times 1 plus x bar y times 1 plus xz times 1 plus x bar z times 1. And this will be xy times z plus z bar plus xy bar times z plus z bar plus x bar y times z plus z bar plus xz times y plus y bar plus x bar z times y plus y bar. So when I distribute, I'll get xyz plus xyz bar plus xy bar z plus xy bar z bar plus x bar y z plus x bar y z bar. Then here I have xzy, but I'm going to write it as xyz. And xzy bar, I'm going to write as xy bar z. I have x bar zy, so that will be x bar yz plus x bar y bar z. And finally, let me just look and see if I have terms that I can combine. So I'll start by looking at the term xyz. It appears that I do have this term twice. So I'm going to use the idempotent property and write this is just equal to xyz. And I'm going to look for terms with one complement. I can see that I have plus xyz bar and see if I have any other term. I don't see that one again. So then I'll look at xy bar z. I do have two of those. I have xy bar z, xy bar z. So I'll use the idempotent property to say this is xy bar z. Then I have x bar yz. And again, I have two. So here's x bar yz, x bar yz. So this will be plus x bar yz. And those are all of the terms that have one complement. Then I have xy bar, xy bar z bar. Here I have x bar yz bar here. X bar yz bar, and lastly I have x bar y bar z. So this will be the sum of products expansion of the function x plus y plus z. We end up with xyz plus xy z bar plus xy bar z plus x bar y z. And then I think I should have here x y bar z bar, forgot to put a bar there, plus x bar y z bar plus x bar y bar z. The last example here is f of x, y, z is equal to x. So I do need to introduce two variables, but it shouldn't be too bad since I just have the one term x. So I'm going to first say that x is equal to x times 1. And x times 1, I'll replace the 1 by y plus y bar. So distributing, I have xy plus xy bar. Now to each of those, I need to introduce z. So I'll write this as xy times 1 plus xy bar times 1. And replace 1 by z plus z bar. So I have xy times z plus z bar plus xy bar times z plus z bar. When I distribute, I get xyz plus xyz bar plus xy bar z plus xy bar z bar. And it doesn't look like I have any common terms, so this will be the final answer for the sum of products expansion of the function f of x, y, z equal to x. And that is the last problem that we had here, so we'll conclude the video.